Emotions are pretty cool. We are all intimately familiar with them. They're every day. However, when you try and get a handle on them, you also realize how complex and nuanced these things can be. People say that they drive human experience and behavior, that they condition our actions, and some even say that there is no thought without cognition. And also they are useful in organizing meaning. So I've been fascinated with emotions for many years now, and much of my research has been on that. So a lot of this talk is going to be on the search for emotions in language. And I use Nemo as my metaphor for emotions because, as I said, whenever you try and get a handle on things, it can be fairly slippery and tricky. But as you work on emotions, you also see that it's hard not to get in touch with certain other characters like creativity because creative things have an emotional punch to them, so they're strongly tied there. And also to things like fairness, because if you have disparate emotions towards different demographics groups, let's say, that leads to unfairness, or unfairness can elicit strong negative emotions as well. So some of my recent work has touched on these things as well, and I'll talk about that as well. All right. Usually when I start this talk, I ask people, how many emotions do you think there are?
I'm biased by the 6 one emotion.
Okay. Anybody else want to take a stab? How many total emotions there are? Yeah. Okay, hundreds. Yeah. Yeah, so turns out there's no real strong agreement on this. It's also surprising given, again, emotions are something we're all intimately familiar with, but we don't know how many there are. Some cognitive scientists say that you've got something like 500 to 600 different emotions. But of course, again, it is tricky because the boundary between where one emotion ends and another emotion begins is a little fuzzy. They're not really not overlapping. And also, what is an emotion and what is not an emotion can be a tricky question to answer. People have been looking at emotions for a long time. For example, Charles Darwin. And when I first heard about it, I was like, why is Darwin looking at emotions? I thought he's into origin of species. And if you think about it, it makes sense because when his theory came out, it was still very revolutionary. And he was always thinking about how do I convince people that there are these strong ties between man and animals. And emotions was one such thing. He even had a book on it, The Expressions of Emotions in Man, that came out 13 years after his seminal book. But as time went on, people sort of talked about emotions in a different way. They weren't thinking that emotions are all, they were thinking emotions are very culturally dependent until you had, this researcher, Paul Ekman, who at the time was a little Sean Connery-esque, came out of the woods of Papua New Guinea and said, hey people, I've gone everywhere and I've shown people these 6 photographs, and whoever I show it to, everybody says this is happiness, this is joy, this is sadness, this is anger, and so on for these 6 emotions. Even here in Papua New Guinea, where they've not seen people from the outside or anything, they associate the same emotions to the same facial expressions. So clearly there must be something special about these 6 emotions, and that energized the psychology community, and there was a lot more work on it. But then people started coming up with more theories. Plutchik says, no, not these 6, I mean, not just 6, it's also the surprise and anticipation, so we've got 8 basic emotions, but there are many theories of emotions that way. Different from that sort of basic emotion or categorical emotion theory, in the 50s and 80s, another theory also developed in terms of how do we capture emotions. And this was based on seminal work by Osgood and Russell. And that idea was that, their factor analysis methods showed that you can capture emotions by 3 orthogonal dimensions. One is valence. This is the sentiment or positive, negative, or pleasure, displeasure dimension. You have arousal. This is the active, sluggish dimension. And you have dominance, which is the powerful, weak, or in control of the situation, or the situation is out of control dimension. So when comparing any 2 words, we can compare them along these dimensions. So we can say, for example, that banquet is much more positive than funeral. We can say nervous indicates more activity than lazy. And we can say queen indicates more dominance or strength or powerfulness than delicate. So since I had the opportunity to work on emotions for about 8 or 9 years now, I had the chance to work on both of these models and not just one, which is also nice because then you can look at how these emotions interact with each other. And overall, my talk today has two broad parts. So one part is what I call the search for emotions by humans. This is where you've got human annotations of words, phrases, tweets, SMS messages, and so on. And the second part is where we develop automatic methods to automatic machine learning systems to detect emotions in text, which has all kinds of advantages and applications, like in personality trait detection, well-being, detecting stance, and so on. And while when I started this work, I was much more interested in this second part because I'm a computational linguist. As time went on, I realized that I was far more fascinated with this first part, because once you start creating really large resources that directly capture emotions felt by people, then you can make inferences about how people use emotions in language, and I find that to be very interesting. All right, so I'll not talk about this particular work very much, but this all began, for me at least, with the building of the NRC emotion lexicon, which was a crowdsourced lexicon where you had 14,000 entries, and for the first time you had this really large resource where you had categorical associations with the 8 basic Plutchik emotions. When we were creating this lexicon, we also piggybacked another annotation on top of it, which said what color comes to your mind when you think of this word. And so that resource is also available. But again, I'm not going to be talking about that today. It was really nice that the NRC emotional lexicon was really, took off, got a life of its own. People were using it all over the place, not just in computational linguistics, but in psychology, digital humanities, robotics, public health, and so on. It was also used by your everyday amateur data scientists. Somebody gets up one morning and says, I want to analyze the discourse in the Brexit tweets. They use the NRC emotion lexicon. You want to analyze Radiohead songs about the emotions there, or the Trump tweets or election debates. People have been using it for all sorts of purposes, which is great. They've also been used for all kinds of non-scientific, or in some cases, this art work, like this wishing wall project, which was demonstrated in various prominent museums in Europe. So we're always happy when the lexicons are used that way. And last but not least, we license it out commercially as well. But for research, it is free. What I'm going to talk about today is the work that I did last year, which after many years I circled back from created this large resource for basic emotions, but I always had it in mind that I want to create a resource for this valence, arousal, dominance as well. But of course, it's more challenging because now we want to put words along these dimensions, and so we have to get these fine-grained ratings from people, and that's a challenge. But of course, if you're doing it, why not do it for 20,000 English words? That seems like a good number. And we also want to do it at a very fine-grained level, because we know humans are capable of pretty fine-grained distinctions among sentiment. We don't just want 5 levels of valence, arousal, and dominance, for example. So VAD is a very prominent thing. People have been studying in the psychology field about this for a long time now, because as I said, there are the 3 core dimensions of connotative meaning. So they use it for all kinds of evolutionary studies and just understanding language and people. So surely people must have created some resources like this before, you say, and yes, they have. The most popular one is NU. This was the first one of the sort. It came in 1999, had about 1,000 words. A few years back, Warner et al. Created a much larger 14,000 word lexicon, and some of these lexicons have been translated to other languages as well. That allows them to look at the psychoevolutionary things across cultures, and that's been fun work to watch. What's been common with all of this work is they've all used rating scales, and you are familiar with rating scales, right? You've seen things like this. Or something like this, where this is what was used in ACL. This is the slide's coming up next. This is the movie review thing, or this is the ACL final acceptance sort of overall score ratings that people give. We've seen this sort of thing before. But there are problems with rating scales, and there are many. For example, there's a fixed granularity. You're stuck with the granularity once you choose it. You can't say this is 4.3. It's difficult to maintain consistency across annotators and even within an annotator. Once you've annotated 100 words, here's another word. What should I give it, 7 or 8? And how does that vary with these other words? Really hard to do. The scale region bias, that's the bias that people have of not giving extreme values. They like to give values in the middle, and so on. So how do we fix this? There is a way to fix this, and again, you know it. It's called this sort of comparative annotations, where you give people, let's say, a pair of items, and you say which is more positive, or which is more angry, and so on. And immediately, all of these biases that I showed you earlier, they go away. However, there is a problem. The problem is that instead of having to annotate n items, now you have to annotate n square items. And when you have 20,000 terms to 20,000 square, quite a large number of annotations. So what we want is to preserve the comparative nature of annotations, but we want to reduce the number of annotations we have to do. And that's where we stumble on this method. It's called best-first scaling. How many here have heard of best-first scaling? Yeah, it's not very popular. It has its basis in 1950s mathematics choice modeling and psychophysics, but it was really developed in the 1990s by Louvier and Woodsworth. The core idea here is that you give people, instead of 2 items that I said, you give people 4 or 5 items, let's say 4, and you ask which word is the most positive and which word is the least positive, or whatever the property of interest that you're looking at, most and least. The annotation efficiency comes from the fact that just from that response, you now know 5 out of the 6 inequalities involved here amongst A, B, and C, and D, right? So if A is highest, D is lowest, then you know all of these inequalities. The only thing you don't know is the relation between B and C, but that's okay. Each of these BW has 4 tuples. I'm calling them 4 tuples because you've got 4 items. You can be annotated by multiple people. And then once you have all these annotations, you can get a real valued score for each word along this dimension by simply taking the percentage or proportion of times an item is chosen as best minus the proportion of times it is chosen as worst. This gives you a score between -1 and 1, or 0 to 1. You can rescale it to whatever range you want. But the core idea is if an item is much more positive, it will be chosen as the best more often, and so it will end up getting a higher score than another item out there. And there are other ways in which you can generate these scores other than the formula that I've shown here. There are more complex optimization algorithms, but this one has been empirically shown to work really, really well, so we use it. Okay, so that was great. So what this allows us is now we are keeping the comparative annotation, and it's been empirically again shown that instead of having to annotate n square items, when we annotate just 2n items, we can get pretty reliable annotations. And we had a 2017 ACL paper which compared best-first scaling with paired annotation and showed you that the ratings are pretty reliable. So, okay, so that's the method we choose, and here's how the questionnaire looked for the valence annotations, for example. So we are asking which of the 4 words here is associated with the most happiness, pleasure, positiveness, and so on, or least unhappiness, annoyance, negativeness, and so on. And you had a similar question for which of the 4 words below is associated with the least happiness or the most unhappiness. And similar questions like this, pairs of questions for arousal and dominance. Of course, we take great care in terms of having quality control of our annotations. A portion of our data was 2% or so was manually annotated by me to form as gold questions. These are very easy, clear, where the answer is very clear. And these are thrown in between, mixed with all the other annotations, just to make sure that people are annotating, with interest and with, are not doing malicious annotations. So if an annotator gets one of these gold questions wrong, they're immediately told, hey, you got this wrong, and maybe you want to get your act together. And with Crowdflower, the platform we use for this, they keep a score of what is the percentage accuracy on these gold questions. If a person's accuracy on these gold questions falls below a certain level, in our case, we took that to be around 80%, then we say, thank you very much, no more annotations left for you. And they are, shooed away. But we pay them fully for their work. And behind the scenes we discard all of their annotations because we no longer trust their annotations anymore. So we did this sort of annotations for valence, arousal, and dominance. These are 3 separate questionnaires, but you had the same 20,000 words for all 3 annotations. We chose the words from the NRC emotion lexicon, which itself had words that were high-frequency words, but not function words, and also from certain other resources like Warner lexicons because we wanted to compare with them, and we chose some terms from tweets. Overall, we ended up getting close to around 800,000 annotations for this project. We use the same method I told you before to get the scores of the terms. We linearly transform the scores to a 0 to 1 range, which can then be used to rank all these words along these dimensions. So here's a look at some of the example words in this lexicon. These are the most extreme words, the words on the 2 ends of the 2 dimensions. So for valence, you have in the most positive, you have love and happy, and in the most negative, you have toxic and nightmare. For arousal, you have abduction and exorcism on one side, very high arousal, mellow and siesta on the other side, very low arousal. That sort of makes sense. You have powerful and leadership on one end for dominance, and empty and frail on the other end for least dominance or least in control of the situation. But of course, you can. It's totally fair to say, hey, Saif, that looks like just some examples. How do we as scientists, we need to really evaluate this. How do I know this data is good? And that's an absolutely fair question. The whole lexicon is publicly available, so you can download and look at it yourself. But in terms of the actual empirical evaluation, here's what we do, and this is a fairly standard method of evaluating such things. It's called average split half reliability. What we do here is we take all the annotations and we split them into two halves. Half of the annotations go on this side, half of the annotations for each of the words go on the other side. So now you have only half of the annotations for all the words here. You complete the whole method of getting the scores for the words using the formula that I showed over here, and then you rank all the words here. And you do the same ranking of all the words here from just half of the annotations. And then you see how similar are these two rankings. So you can use something like Pearson correlation or something for that. The more similar these rankings, it means that we have more confidence in these annotations, right? If I repeat these annotations again and again, if I get wildly different rankings, then I'm like, I don't know what I'm getting here. But I've been consistently getting very similar results, then I have more confidence. So we do this thing for 100 times and get the average Pearson correlation. And here are some of the results. First, I'll show you the results for the split half correlation for the Warner et al. Lexicon, which is about close to 14,000 terms. And you can see for valence, they got a correlation of around 0.91, which is pretty high. It can go up to 1, higher the better. So valence is great. For arousal, 0.79, dominance, 0.77. And the way they explained it is, well, valence is a strong signal. Arousal and dominance are secondary dimensions. And so it's not surprising that's a little lower there. However, if you look at that paper carefully, you notice that their valence to dominance correlation was also 0.71. That means that dominance annotations were really very similar to the valence annotations. And that's somewhat troubling. Are we really getting something different from valence here? And of course, one of the reasons we did it was because we thought, we didn't want to use rating scales like what Warner et al. Used. We wanted to use these comparative annotations. So here are our numbers, and this is for the exact same 13,915 words. And for valence itself, we got a nice little bump to about 0.95. But for arousal and dominance, the jump is much huger. Here again, we get like 0.91. This last row is for the full data set, so not just the Warner overlap. And again, the numbers are pretty high, around 0.95 to 0.9. So this shows that for the first time that even for arousal and dominance, you can get very reliable annotations and close to 0.9. Also, our valence to dominance correlations were around 0.48, again, much lower than what Warner had. So there's still some correlation between valence and dominance, which is not surprising, frankly. Usually, if you're in control of a situation, have power, you are happier and it's more positive. But there can be negative things like tyrants and things like that, where it doesn't correlate. So that was just showing how reliable these annotations are. But another question to ask is, how different are these lexicons? Okay, maybe you're showing that high reliability numbers, but is your lexicon really that different from the rankings that you get from the Warner et al. Lexicon? And that's what these numbers are here to show. This is a correlation between our lexicon valence and the Warner lexicon valence. And that was around 0.81, which again is not very high. It's significantly a drop from 0.9. And as you go from arousal to dominance, you see that our correlations really drop off, which shows that this lexicon is quite different from the lexicon that you get from Warner et al. All right. I have more details of this last experiment in an ACL paper from earlier last year. But I just wanted to hint at some of the additional work we did in that area, in the area of fairness. We know that human cognition and behavior can be impacted by various socio-cultural and evolutionary factors, and that these factors can impact different demographic groups differently. So if you consider gender, for example, we know that men, women, and other genders are far more alike than they are dissimilar. However, for thousands of years, they've faced different social power structures and unequal power relations. And an interesting aspect that gender studies likes to look at is, what is the impact of all of this on these different demographic groups? How are they different? How does this impact their language, for example? So since valence, arousal, and dominance are considered the core dimensions of connotative meaning, we thought this is a good resource to also look at how these demographics view the world around them with all these 20,000 words and look in terms of their VAD. And unlike other work, which I think falls into a bit of a trap where they say, well, this demographic group gives higher scores for words and that gives lower scores, so these must be more emotional or something like that. I think that's a little bit of a tricky ground because the numbers might actually map to the same emotionality in your head. So what we do instead is we are looking at what is the commonality in different demographic groups. So for example, if I give 100 words to men and I ask them to rank them by arousal, and if I give 100 words to women and ask them to rank them by arousal, which group agrees amongst themselves more? And what we found was there were significant demographic differences like this. For example, women had a significantly higher agreement amongst themselves when they are ranking terms for arousal than men. In contrast, men had a higher shared understanding amongst themselves when ranking words for dominance and valence. We also had differences for age over 35 versus age less than 35, and also for various big five personality traits. So for example, extroverts and those open to experience had a higher shared understanding of valence, arousal, and dominance than those that were not. And this is in more details in this paper, but this raises more questions than it answers really, because it now tells us, okay, what is the cause of these differences? Are these just evolutionary? Are these sociocultural? Are these appropriate? As in, that's just the differences that we can celebrate, or some of these are a result of these unequal power relations and experiences that different demographics have felt, and which have caused these things, and in that sense, inappropriate. All right, so that was a big VAD lexicon, but I didn't just get up one morning and decide to annotate 20,000 words with best first scaling. We were playing with best first scaling for a few years. Before that, we created many other smaller lexicons. We also have, for example, we took all the NRC emotion lexicon, all the anger words in it, and did best first scaling on that. So now we have an intensity of anger for all those words, similarly intensity of sadness, and so on. We have lexicons for English and Arabic. We have lexicons for Twitter specifically. We have a lexicon that looks at phrases, that looks at negations, modals, adverbs, and so on. We even have a lexicon where you have one word is positive and one word is negative, like happy accident, and so on, where it's an interesting thing to study how the sentiment of the whole phrase can be determined from the sentiment of individual words in it. As I said, since we now have both the VAD and the categorical word lexicon, we can look at correlations between these two lexicons, and we have a paper on that. One of the hypotheses there was, do all the anger words fall in one area of the VAD dimension and all the sadness words in another dimension? And what we found was no. The negative emotions are hard to separate in terms of the VAD emotions. I mean, joy is obviously in a different area. Here's an example of one of those Twitter lexicons. You can see some of the words there. We've got hashtags, conjoined words, creatively spelled words. And before I end this first section on human annotation, I also want to say that after many years of working with text, we got a little bored and said, hey, let's annotate a different medium. And in this case, Peter Turney sort of convinced us to explore this area of art and what emotions it evokes. The picture there is of my son in daycare. I don't know if he got the grasp of what art really is, or the medium at least. But anyway, our quick overview of our project for that. This was again last year, where we took 4,000 pieces of art from 20 different categories in 4 different styles, so 200 for each category, and we annotated it for things like ask people to tell us how much they like them, what emotions this art brings to mind, is there a face or a body in this, and various other things like that. And this data is made publicly available in case you want to do interesting research on top of it. And one of the motivations for this is that more and more of the museums are putting huge amounts of art online. And if we can get this art much more accessible to people, then that will be great. Because currently the meta information is things like who's the artist, what style it is. But what if you could say, hey, show me some post-Renaissance peasants who are very angry, and then this can get you some of these paintings like that. Or you can arrange different paintings by the mood that they express, and so on. You can also have deep learning models that generate art and so on, right? So lots of interesting stuff there. All right, I'll move on to the second part of the talk. This is on detecting emotions automatically. And when we first created the NRC emotion lexicon, I was interested in how can we showcase the power of this large lexicon. And I was drawn to this idea of showing emotions in stories, because in stories you have an ebb and flow of various emotions. And turns out, I didn't know it then, but I was not the first one to think about that idea. There's a guy called Kurt Vonnegut. How many here have heard of Kurt Vonnegut? Okay, a few, very good. So he's considered one of the one of the biggest writers of the last century. He had this little talk. I'll play you a few seconds of that.
Universal appeal. His singular view of the world applies not just to his stories and characters, but to some of his theories as well.
Well, there's no reason why the simple shapes of stories can't be fed into computers. They are beautiful shapes. This is the GI axis, good fortune, ill fortune. Sickness and poverty down here, wealth and boisterous good health up there. Here's the very middle. Now, this is the BE axis. B stands for beginning. E stands for electricity. Now, this is an exercise in relativity, really. Is the shape of the curves are what matters and not their origins. So we'll start a little above average. Is why get a depressing person? We'll start... The whole thing, we call this story Man in Hole, but it needn't be about a man, and it needn't be about somebody getting into a hole. But it's just a good way to remember it. Somebody gets into trouble, gets out of it again. People love that story. They never get sick of it. All right, not copyrighted. Another story, also a beautiful curve and easily fed into a computer, called Boy Gets Girl, but it needn't be that. Just a way to remember it. Start on an average day, average person, not expecting anything to happen a day like any other. Find something wonderful, just loves it. Oh, God damn it. Got it back again.
Idea in 1983 as a master's thesis, which was promptly rejected by his committee, but he still maintained unto his death that idea was one of his biggest contributions to this space. Anyway, the video actually goes on a little bit as well. It's quite funny. I encourage you to look at that at YouTube later. It's the third curve in green there. Anyway, as you can see, this raises plenty of interesting questions. For example, can we automatically track the emotions of a novel from beginning to end? Can we track the emotions of the individual characters? Can we track the emotions that characters have towards other characters? What are the shapes of the various stories? Are there just like 6 or 10 canonical shapes and everything is a tiny variation of one of these shapes? Or do we have an infinite variety of emotional arcs in our stories and things like that? So really fun questions to ask. When we first got in, as I said, I had a undergrad, Tony Yang, who had come over, and we said, let's look at something simple. Can we just track the change in the distribution of emotion words in this novel? So just to showcase the power of this lexicon, right, that you can do this sort of thing with this. And so he created some of these visualizations. On top, you have As You Like It, more positive emotions playing a bigger role. In the middle, you have Hamlet, and in the bottom, you have Frankenstein, where the fear emotion is more prominent, except somewhere in the middle it goes down a bit. You know, the monster makes friends with the little girl in the village and so on. But soon at the end, you see fear is playing a dominant role. Since we did that, there's been lots of interesting work, including this package by Matthew Jockers, who to allow people to upload their own novels, and using the emotional lexicon, you can generate these novels. There's work by Dodds et al. On looking at emotional arcs, and they claim that there are only 6 canonical emotional arcs. I'm less sure about that, but it's interesting work, and it makes us think more about that area, which is great. we were distracted by a different project. Soon after we did this, I was contacted by an NYU art student who said, hey Saif, I like how you're drawing these emotional curves from novels, but what I'm interested in is data sonification. And I was like, what's data sonification? It's about conveying information through sound. And I was like, that's cool. And so her idea was, can we take these arcs and then generate music that somehow captures the emotions in these novels? And I was like, wow, that seems great. It's not easy. I wouldn't know how to evaluate it, but it seems like a fun idea. Let's do it. And so Hannah's idea was pretty straightforward. There have been established studies that say that major keys are associated with happiness, minor keys with sadness. In some cultures, this might be flipped. Fast tempo is associated with happiness and excitement. And if you play more consonant notes, it conveys a sense of joy and calmness, while if you play more dissonant notes, it conveys a sense of anger, excitement, and unpleasantness. So our system, which she calls transpose, has placed 3 simultaneous piano melodies, and based on the 3 emotions that are dominant in that the NRC emotion lexicon determines from the novel. So let me play you some of the music. And before that, so one of the key ideas is also that if at a particular part in the novel you have a lot of excitement or anger or something like that, you break it up into many small chunks and you play many more dissonant notes. While if it's more calm and soothing, in that novel you play longer consonant notes. So this particular one is for Peter Pan. And this next one, decidedly darker, is Heart of Darkness, just for contrast. So we put clips like this for various novels out on the web at musicfromtext.com, and it was great to get like 300,000 clicks in just a few months right after that. It got a lot of popular press attention as well, so which was really nice. And actually, 2 years back, the group contacted Hannah and said that, hey, we have this event on industry and humans thing. We will give you some text. Can you produce some music from transpose? And then we'll have a live orchestra play that music. So this was played in front of the Louvre Museum in Paris. So pretty awesome. Anyway, I'll come back to this. Look, you remember we looked early on about Paul Ekman and about this basic emotions, how this whole story started. Turns out there was still another twist to this. In the late 1990s, there was a researcher called Lisa Barrett. She was a postdoc at University of Waterloo, and she was replicating some of the experiments that Ekman did and found that they were not really working. You get really low agreement scores. People don't really agree on these photo tests that he had. And so she's been raising this question further on as to whether this whole idea of basic emotions makes sense or not. In fact, she shows how if you change the parameters in a certain way, which is the right way according to her, then all this agreement drops. She is now a distinguished professor at Northeastern University. She is doing active research in this for the last 15 years. And if you go to some of the psychological conferences these years, it's still an area of active debate whether there is such a thing as basic emotions or not. And so that calls into question some of our early choices, right? So what about those emotions that are not basic? How do we get a handle on them? And of course, distant supervision comes to our aid over here, and I'm sure all of you are familiar with this. But if you take tweets like "some jerk stole my photo on Tumblr," #grr, #angry, this hashtag here is like a self-label for the rest of the tweet, because the rest of the tweet on its own is also conveying anger. Right? So it needs to do that for us to be able to use this as a self-label, because now we can take this tweet, take out the #anger from that tweet, use that as a label, and learn what other words in this tweet are indicative of anger. Of course, not all tweets are, satisfy these criteria. For example, people can tweet with sarcasm, and then it's no longer a good label. So we did some work way back in 2012 on getting a bunch of data like this and showing that actually the signal that you get is actually strong, and you get very good results, or at least competitive to other traditionally annotated data. You get results there. However, what is good is not just that. What is good is that this sort of approach now frees you from that bottleneck of having to be able to deal only with 6 or 8 emotions, because now you can model hundreds of different emotions for which you have such a data. And we showed in some of our work where if you model just 2 positive or negative in a task like personality trait detection, which is a notoriously hard task for NLP systems, you find that you get some help. If you model 6 or 8, you get some more help. But if you model hundreds of different emotions in the language, then you are better off at detecting personality traits. So it actually moved the needle in a particularly hard task. This is also a way to get lexicons automatically. I talked about doing best for scaling, getting lexicons manually, but you can also get generate lexicons automatically. These tend to have even higher coverage, and they can also have domain-specific capabilities when you do them automatically. So because now that you have these tweets with these labels, you can just do something like point my mutual information and determine which words have a higher tendency to co-occur with the anger hashtag, and then that tendency to occur with this hashtag is an indicative of how much anger association is there with this word. So so in 2013, I gathered some of my colleagues at NRC. There was a call out for a sentiment analysis task, and we said, hey, I've been doing this with emotions, but you can do this with sentiment too. And so we took part in that competition. And frankly, to our surprise, we came first out of 44 teams. These are the results on the tweets data set. We were also first on the surprise test set, which we had SMS messages. And you can see that gap between the number 2 team was even higher. And if you look under the hood, this is sort of the ablation studies where you take red are our results with everything in it, and all the other bars are the results when you take out one set of features at a time with replacement. And so the bigger the drop when you take off this feature, the more useful that feature really was. And we found that the lexicons are particularly useful, especially the automatically generated lexicons here, because we get all sorts of tweet-specific data from that. And the reason I'm telling you about that work is because that directly led to this other work we did in 2016 on stance detection. And this is because as soon after the competition, you had people coming to us and say, hey, NRC, you've got a very good sentiment analysis system. Why don't you build a model for us? And you know what? I've even hand annotated the data for you. You can learn a model specifically for our task. Here it is. And if you've dealt with companies, you realize that this is awesome, because who comes here and tells you we've got labeled data as already here for you, right? So we were very excited. We took the data, and when we looked at the data closely, we noticed that there's a difference. The annotations are not for whether this tweet is positive, negative, or neutral. The annotations are for, does this person like my product or not? Does this person favor my government policy or not? And that is an orthogonal sort of problem than whether the language is positive, negative, or neutral, right? So that led us to this idea that, hey, this is a different task, and it's a compelling task. It's a very useful task. So we framed this shared task at semi-val, where you are given a tweet and a target, which is predetermined, and you are asked, is this tweeter likely to be in favor of this target, against the target, or whether neither inference is likely? So so consider this tweet, for example. Jeb Bush is the only sane candidate in the Republican lineup, and your target is Donald Trump, because let's say you are Donald Trump's election strategist. You care about whether people are going to vote for Donald Trump or not. And so humans can look at this tweet and say, this person is likely not going to vote for Donald Trump. And so the task is, can we ask machines to make that same kind of inference, even though Donald Trump is not mentioned in that tweet at all. In fact, opinion is really towards Jeb Bush. This task is even harder when your target is not really an object or a person. Consider pro-life movement. Humans can look at this tweet and say that this person is likely against the target, but can we ask machines to do the same thing? There's no pro-choice, there are no babies, nothing of that sort mentioned here, but there are some other words that can give you these clues. This is a particularly hard task, but it's very useful because if you're a government that is trying to figure out what do the people at large feel about these issues, then you can have your traditional means of getting this information, but you can also use something like this to gauge from the social media content. So the key information is not here, but we also, with the shared task, provided a huge amount of text where the target word is mentioned. So the idea is, can systems learn various lexical relationships from that unannotated data to make decisions like this over here? So we were very happy that a large number of teams took part in this competition, about 26 or so teams, and there's been a whole lot of work on this, even in other languages, so that's been great. Last year, we organized another shared task. This is in some ways more traditional, but it was different because rather than just saying whether this statement is positive, negative, or neutral, or anger or not anger, we had a task where we said, can you detect the intensity of anger? So if I give you 1,000 tweets, can you order them from no anger to maximum anger, as felt by the speaker? It had a bunch of other tasks as well, all for sentiment and emotion classification and regression. We have English, Arabic, and Spanish data sets. We had 75 teams and 200 participants. This was a record for semi-val last year, although this year, there's more and more participation in semi-val. So since we had so many teams participating, it was a nice chance to take a quick survey and see what are people using right now in 2018. And so you can see from here, for example, that surely there's a lot of these CNN, BioLSTMs, neural stuff, but you also see lots of SVMs and SVRs. But that can be a little tricky because sometimes they have these many neural systems and they have an SVR on top of it. So these systems are complex machine learning systems. If you look at the features they use, you see that word embeddings are the most popular. Again, no surprise there. But the affect lexicons are the second most popular and still very useful because they help bias your learning from the beginning. So a lot of people find these lexicons still to be very useful. Another new thing in the shared task was for the first time we had a separate evaluation for bias towards race and gender. This is the first time in a semi-eval task where it's not about how accurately you're doing the main task, but we also want to evaluate how appropriate your task is in some other aspect, right? And I'll tell you more about it, but it's an interesting question to ask, do machines make fair decisions? Because that's what is leading to all of this. And on the one hand, yes, they're not looking at my skin color, they're not taking bribes. And when they first came on in the 60s and 70s, they made a huge difference in terms of fairness. However, more recently, the systems are getting more and more sophisticated as they are training on huge amounts of data generated by humans. And now we see that some of our inappropriate biases are seeping into these machines as well. So that's why I'm sure you've heard of these examples like the racist Microsoft chat system. You've got the Amazon's recruiting tool that was giving, it was not really deployed, but they wanted to deploy it, but they found that it was giving, if you have women's chess championship or women's women's club president, then it would downgrade your CVs. Or you have face recognition systems that are really good if you're a white male, but not horribly, horribly bad if you're an African American woman. And you also have recidivism systems that are in place right now in the US, where your parole is determined by your PIN code, or the location of your neighborhood, and this penalizes those living in African American neighborhoods. And of course, the reason for this is because these systems are built on human data, and while we might have this opinion that, oh, this data is coming from upstanding people from the society, in reality, the picture is more like this. We've got decidedly flawed characters, people have flaws, and that is reflected in our language, and then that's reflected in our machines. So here's another example. If you look at the Google Books corpus, is one of my favorite resources to use, where they've OCR'd these gazillion books from 1500 to 2000. And if you look at occurrences of the words son and daughter, you find that occurrences of son are twice as much as occurrences of daughter in our collective set of books out there. That itself is a bias. There might be some reasons for that, but that is what our kids are exposed to. And if you look at occurrences of genius son and genius daughter, the discrepancy is even larger. Right? So these are the data sets that our systems are using, and there is no doubt that that will impact how they behave. So I was inspired to look at that because of this other work done by somebody who was working at Google, where they had access to the query logs. And so they found that parents of little kids search way more for, is my son gifted than is my daughter gifted? Is my son a genius than is my daughter a genius? And so he was surprised by that, and he was like, okay, in what cases do parents look more for their daughter? And he found that they do that in the case of physical appearance. So is my daughter overweight is searched way more than is my son overweight. Right? So he said that he already had a dark view of the world, but after all that research, it was particularly, he even has a great book on this sort of work. This is way back, 2011, when we were showcasing the power of the lexicon in this Google Books thing, one of the things we looked at was what kind of emotion words occur next to occurrences of man and woman in these books. And there too, you see a huge discrepancy. You see next to women, you see way more positive and joy words around than compared to men. And around man, you have way more occurrences of anger words than women. So it's not surprising that if you build sentiment analysis systems based on data, you will get discrepancies for different demographic groups. So that's where Svetlana and I created this data set called the equity evaluation corpus, where we have pairs of sentences that are identical in every aspect, except they differ in one word. One refers to a male, one to a female. One refers to an African American name, one refers to a European American name. One refers to a son-daughter kind of thing, and one to a son-father, a relationship where it's a male, one a relationship where it's a female. And what we wanted to look at from our competition, we had 200 plus systems participating here. We wanted to see are systems consistently giving higher scores to one gender for emotionality than the other gender. And what we found was more than 75% of the systems were biased. I don't have the full details here, but the details are in the paper. Most of the systems, in fact, all of the systems that were doing well on the other test set were actually showing systematic bias. So we need a lot of work in this area, and a lot of work is going on already by various people around the world on identifying and tracking inappropriate biases in the systems, but also in language, so that we can track how that is playing a role. So in summary, what I've shown you here are several lexicons that capture word emotion associations. I talked to you about comparative annotations, how they are really useful to avoiding bias, and specifically best worst scaling that can get you reliable annotations with very few annotations. We had also talked about some new tasks like detecting stance, emotion intensity, generating music, and detecting emotions in paintings. All of our data and these tasks is freely available. And finally, we investigated the use of language, especially for creativity and fairness. And fairness is particularly important because these days our NLP systems are incredibly pervasive and in the lives of, in the rooms and the homes of all the people around the world. And if we don't get our act together, history will not look back kindly at NLP. But this is also an opportunity because we have a chance to do something really impactful. So with that, I'll leave you with this slide. As I said, all the resources are available on my webpage. I showed you a picture of my son, so here's a picture of my daughter. And I'll be happy to take your questions.